In early ages, mathematicians didn't have enough paper to do math. So in order to save the paper, they invented this symbol, summation. I'm just joking. But this symbol did actually confuses me for years and still student struggles with this symbol. But in this video, I'm going to remove the fear of summation from you. So now let us consider first 10 digits. So it would be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus so on and on up to 10. So before writing it in summation form, firstly we have to know the upper and lower limit. So from here you can see the lower limit is your 1, and the upper limit is 10. Okay, so after finding upper and lower limit, just you have to write is your summation, right? And you have to add a new variable. Okay, new variable associated with this summation. So let us introduce new variable as our I. Okay, it's not imaginary number, but it's I. And the lower limit you have to put is like this. So I goes from 1 to 10, right? And if you want to open this summation, you can actually do it like this. So you start from basically 1 and you have to use plus sign and 2 and then plus, then 3 plus 4 plus so on and on up to plus 10. So this is the basic idea behind writing the summation. So let us consider another example that goes like this: 1 plus 2 plus 3 and so on and on up to infinity. So the basic idea of writing summation, this whole bunch of mathematics in terms of summation is just you have to find upper and lower limit. So you can see the first you have to add a new variable. Let us say for this our case, let us say the k be our new variable, and the k goes from where? The k starts from 1 and it goes to infinity. And if you want to open it, you can do the same method that we had done in previous way, that is 1 plus 2 plus 3 plus so on and on up to infinity. So this is the idea behind writing the summation form. So first you have to identify your lower limit and the upper limit, and you have to add a new variable, and the whole writing this equation can be replaced with this much expression. So this is another way of writing summation. So nerds, let us consider another exponential expression. So e raised to x can be expressed like this. So if you use Maclaurin's infinity series, right? Or you can do it by using Taylor series, whatever you want. So in order to write this whole bunch of expression in something like this, firstly you have to identify your upper and lower limit. So I am going to write it as like summation. Okay, so the very first thing, the starting phase is, let us write it as x raised to 0. So writing 1 and writing x raised to 0 is same thing. So our variable, let us put a new variable. We had used I as variable, k as variable. Let us introduce new variable. Let us say n be our new variable. Okay, so the n starts from when? Where? It starts from 0 and it goes up to infinity. Okay, so we are writing the summation for the exponential function. So and you can see from here, in each term the power increases by 1, right? So if I write x raised to n, so if you put 0, you get x to the 0, right, like this. If you add summation x to the n and n goes from 0 to infinity, if you open this, you have to firstly put x raised to 0, x raised to 1, x raised to 2 plus so on and on up to infinity. So this makes sense because each term is increasing by power of 1. Okay, and what about this below term? So this is going to be like what? This is just like 1 over n factorial, and n goes from 0 to infinity. So if you put 0, you get 1 over 0 factorial, plus if you put 1, you get 1 over 1 factorial plus so on and on. So you can write, if you combine if you merge these two equations in a same expression, you will end up getting x raised to n over n factorial. And if you didn't convince with this expression, you can actually open by using the power, just by using your numbers. So if you put n is 0, you get x raised to 0, and here is also 0 factorial, okay, plus you get x raised to 1 and 1 factorial plus x raised to 2 over 2 factorial, and this matches with this expression. So this is the another example. So in next section we would use sine and cosine function, and for the sake of your convenience and for your in order to brush up your knowledge, you can actually try exponential negative x by your own. So just replace x by minus x in each term here and do this, and you will get the very much beautiful elegant summation, right? So nerds, let us take another example, trigonometric functions. This is cosine of x, and if you expand it like this, you will end up getting this function. Okay, and most of the time you have heard in your junior classes, you might have heard the cosine of x is approximately equals 1 if you neglect this higher term. And when I was in my junior classes, my teacher told me the approximation of cosine of x is approximately 1, and I really didn't understand why this approximation works. And after my plus 2, I had joined my bachelor program, and once I understand the Maclaurin series, Taylor series, right, and then I had seen this approximation and it immediately hits me. Yes, this was the thing that was done by professor in my plus 2, and that connects there. So we want to write cosine of x in terms of our summation form, and you can see from here, if I write x raised to 0, it would be the same. Okay, so since you can see from here the signs are alternate, the positive negative positive negative, okay, okay, first we have to use our upper and lower limit. So the lower limit is our what? The lower limit is our 0, okay, and it goes up to infinity, right? So for the sign convention, right, plus minus plus minus plus minus plus minus, we have to use minus 1 raised to power n. Okay, so after that, okay, after that you can actually see the power increases by 2 terms in each, and going from left to right, right? So 0 and 2 and 4 and 6, so you can write it as x raised to 2n, okay. Also from you can see the factorial increases by 2 also here in each term, right? So you can write it as 2n factorial, okay. So I think this would be an uneasy for you, but I'm going to do it like this. So I have basically x raised to 0 minus x square plus x4 plus minus x to the 6 plus x to the 8 plus so on and on. Okay, so I would make you feel better for this. So my summation grows from n is equal to 0 to infinity, okay. In order for sign convection, we have to use minus 1 raised to n, okay, and in each term the power increases by 2. I'm going to use x raised to 2n, okay. Okay, firstly check this, don't look at this, just look at this. So once you put n as 0 and this 0, you get this first term 1, or simply you will get this 1. And if you put x as 1, so if you put n as 1, you get minus 1, okay, the sign has come out, and you get x squared, right? And if you put n as 2, so minus 1 is squared is positive, and you get 2 times 2 is 4. So all these things can be done like this, okay. Okay, so I would like to convince you for the below part, that is 1 over 0 factorial plus 1 over 2 factorial. So because you have sign of minus, okay, plus 1 over 4 factorial minus 1 over 6 factorial plus so on and on. And we also want to write it as like this. So you can actually see from here also the sign has alternate positive and negative. So we have to use minus 1 raised to the n, okay. And we have like, you can see from here 0, 2, 4, 6. The power increases by, sorry, the factorial increases by 2 times in each term. So you can write it as, we have n terms, so it increases by 2n factorial, right? So if you put x n is 0, so my variable goes from n is equal to 0 to infinity. So if you put n is 0, you get what? 1 over 0 factorial. Okay, this term. If you put n as 1, you get minus, the sign has came out, and 2 into 1 is 2 factorial, and you can do it like this. So if you want to replace the whole thing in a summation form, this is how we do for it. So right, so, and I would like to give you a problem if you want to do. So expand this. So nerds, let us take the sine function, and if you expand this, it goes like this, and we just want to write it as sine x in terms of our expansion form. We are just introducing the same variable. Okay, you can see from here, if you had carefully watched the cosine term, we had plus minus alternate sign. Okay, here is also the same, so we have to use minus 1 raised to the power n. You can immediately see from here. Okay, and you can see the power increases by 2n plus 1. So if you put n is 0, you get 1. Okay, so like this, I'm going to say like this, summation x raised to 2n plus 1, n goes from 0 to infinity. So if you put n is 0, you get what? X raised to 1. Okay, plus, because you have sign convection, we have to use minus 1, but for the sake of convenience, firstly just see this, because we have already used the negative sign convection, it came out from there. Okay, and if you put x is 1, you get x raised to 3 plus, and if you put 2, you get x raised to 5 plus x raised to 7, and so on. So you can write it as x raised to 2n plus 1. Okay, and you can see from here the factorial. The factorial also increases in the same way. The power 1 here, 1 factorial, 3 here, 3 factorial, 5 here, 5 factorial. So if the power is increasing by this much, the factorial must have to increase by 2n plus 1 factorial. Okay, let's do and take out. Okay, I want to put n as 0, so I get simply x raised to 1 over 1 factorial. Okay, I put x is 1, I get minus sign here, and I had to use 1 here, so I get x raised to 2 times 1 is 2, and it is added with 1, you get 3 over 2, you get simply 3 factorial. Okay, if you put 2 here, n is 2, you get plus sign here, and you get x raised to 5th over 5 factorial plus, sorry, minus, if you put 4 here, sorry, 3 here, sorry, 3 here, you get 7 over 7 factorial plus so on and on. So this works. So if you want to do another factorial, another form, you can do of tangent of x. Just expand this and try to write in factorial form. And if this video is helpful to you, make sure to like, share and comment what will be the next topic for you for the mathematics. So up to there, bye bye, and hit the subscribe button.